Hey guys, what is up? This is Kazi from cleverprogrammer.com and you're watching Codecademy Part 12. Okay, so let's get started and pick back up from student becomes teacher. This is where object-oriented programming is going to come into play. Okay, if you ever heard that phrase, object-oriented programming, or OOP, this is kind of where it comes from. So let's see how these guys go about it. Welcome to this challenge course. Until now, we've been leading you by the hand and working on some short and relatively easy projects. I do agree with that they do hold you by the hand a lot. This is a challenge, so be ready. We have faith in you. Ready. We're going to switch it up a bit and allow you to be the teacher of your own class. Make a grade book for all your students. The example above is just to remind you how to create a dictionary and then to access the item stored by the cat key. So again, you guys are pros at this now because of how much practice we've done. Create a variable, animal sounds, store a dictionary. Within the dictionary, we have, what is this called? It's called a key. And what is this whole thing called? It's called a value. And then the data type here is a list with multiple elements inside of it, meow and purr. So if I access the cat key from animal sounds, I'll get back the value meow and purr. And then this comma separates the next key value pair, and then that comma separates the next key value pair. And it's legal also to have a trailing comma, just like they have it right here. Create 3 dictionaries, Lloyd, Alice, and Tyler. Okay, these are all dictionaries. So if a dictionary, that's how you create a dictionary. This is not a set. Give each dictionary the keys name, homework, quizzes, and tests. Okay, so we're gonna have a key name with name Lloyd. Then we're gonna have a key homework with an empty that right there. Okay, and we're gonna separate it out nicely so it's easier to read. Quizzes, we're gonna have an empty list just like this said, and for tests we are also going to have an empty list. So I'm just gonna copy and paste this, delete that, and just change the names here so I don't have to do all of the work again. Tyler, here we go. Change the name. This is Alice. I'm gonna go here, change that with Alice. This is Tyler, and I've changed that with Tyler. That's done. Have the name, and the other keys should be an empty list. The name key does not have the name Lloyd. Okay, so it should actually be capital L. I missed that, my fault. Alice and Tyler. Okay, that part is done. Now, fill out your Lloyd dictionary with the appropriate scores. Save some time. We've filled out the rest for you. So here you can see for Alice, we have the name Alice. For homework, we have the scores 100, 92, 98, 100. Maybe this means that there were 4 homework assignments. For quizzes, that means there were probably 3 quiz assignments where she got the score of 82, 83, and 91. And for tests, probably 2 tests where she got close to an A and then well above an A, she got a 97. We're assuming it's a course based on 60 D and a 90 is an A. So they want us to fill in that information. I'm going to copy and paste it so I save some time. I don't want to have to type it out. It says make sure to include the decimal points so your grades are stored as floats. So what they're basically saying is that don't do this, but do this. Okay, what's the difference? What's the difference between 88 or rather, do I show you in, okay, let me show you really quickly in Python 2 what the difference is. So if I open up a terminal here on my computer, I'll show you guys maybe in some other video how you can use terminals, but this is a Python 2 environment that I have opened up here. Now I'll show you the difference between maybe 88 and 8.0 or 88.0 and 88. So let's do 88. And this should not be divisible by 3, but you see you get a 29. But now if I called it 88.0, I get the more correct answer, which is 29.3333. So floating number tells it when you're dividing, like, hey, I want it to be shown in the decimal place. Basically I don't want just integer division. Okay. So in Python 2, that is important. So that is one point why they're using floating numbers, and they're saying this will be important later. Put it together. Now let's put the 3 dictionaries in a list together. So we got the 3 dictionaries, and they want us to put like Lloyd one dictionary, and Alice in the other dictionary, and Tyler also. So they want us to put all 3 dictionaries in a list and call this list students. Okay, so that's cool. Now Lloyd, Alice, and Tyler are actually something a lot more complex than very simple things that you're used to doing up until now, right? So let's go and practice with them and play around. So I can say print Lloyd. If I printed Lloyd, I should say print students of 0. So the first element of students is going to give me Lloyd, which is actually a dictionary of homework, tasks, quizzes, and name. And to access those things, I can simply, since this whole part, right, this whole part is basically this dictionary right here, right? It's just that dictionary. How would I access homework from that dictionary? I would just index it and say homework, right? Pass in that key. And if I did that, I would get back that homework right there. So let's go back. So since this whole part evaluates to that dictionary, I can effectively just index it right over here, and I can say homework. And this will give me the homework scores. Let's say I wanted the homework score of the third homework, right? I would put a 2 here because we start from 0, 0, 1, 2. 2 is the third element. So I'll go like this, and I get back a 75. So if you look into Lloyd, which is student of 0, and if you go all up to Lloyd, line 1, and you look at homework, and you look at the third element, you indeed get a 75. So this whole part evaluates to 75. It prints it out to the screen, and nice. Okay, let's go back. So we have done that where they told us to create a list. All right. For each student in your students list, print out that student's data as follows. Okay, so this is going to be pretty cool. We're going to be using some loops and doing some really cool things. So let's get to it, okay? How would we print out these things? I would say for student in students, right? Print, well, all these dictionaries, notice, have the same keys, right? So the first time we were looping through this list students, again, this variable is arbitrary. I can call it whatever, but I'm calling it student because each item in this list represents a student. So it makes most sense to call it student. And it's a Python convention, and you'll see this very commonly. It'll be like for singular in plural. So for student in students, for orange in oranges, for, you get the point. Okay, so here what we're going to do is we're going to say for student in students, print students, because that's the, or I'm sorry, print that student, and we'll pass in the key right? Because student really is a dictionary. So this Lloyd here is actually a dictionary. So I'm basically doing dictionary and then key, right? That was our dictionary and then key, and that will give our value. So I'm doing that's to print student's name. Now I can do print student's homework because that's the order they wanted in. I'll say print student quizzes to put a parentheses here. I'm getting you guys used to using print as a function, right? So when you switch to Python 3, you will be used to it. And I say when because I know once you get a job as a Python developer and in your future career, if your company is using Python 3, it will be good to know Python 3, right? And eventually all companies and everybody will switch to Python 3. Okay. Let's go right here and paste it, and let's run this loop. You can see that it's printing out that student's what is that printing out? Yep, student's name. Then it prints out that student's homework, then quizzes, then tests. So here Lloyd, you can see his homework, you can see his quizzes, you can see his tests. Then the loop switches to Alice, right, which is a dictionary, and then this part switches to Alice. It looks up Alice's name. This part gets evaluated to Alice, but as a string Alice, right, because this value here is a string, and then it shows Alice right there. And same thing happens with the homework, and I think you get the idea, but I'm not gonna go through the entire thing. Okay, so let's get out of that. Cool. Hopefully this video wouldn't stop because my hard drive is getting full almost. It's okay to be average, they say. Is it really? I thought it's not okay to be average. All right, so when teaching a class, it's important to take the students' averages in order. So again, they're now talking about this, right? 5 divided by 2 gives you 2. 5.0 divided by 2 gives you 2.5. Float of 5 divided by 2 also gives you a 2.5. 5.0 is a float, and calling float on 5 also gives you a float. Basically, it turns that 5 into a 5.0. So this float effectively turns using the float function on 5 effectively turns that into this line right there, and then you get 5.0 divided by 2, and you get 2.5. So it's important to remember that in Python 2 especially, that when you do division, it by default does integer division, which means that 5 divided by 2 will give you 2 instead of 2.5. Okay, so write a function, define a called average that has one argument, numbers. Usually whenever I think plural in Python, I'm thinking, okay, it's going to be a list or a dictionary or a set or something with multiple things, values in it, and not just one integer. Okay, we define a function called average as one argument, numbers. Inside the function, call the built-in sum function with the numbers list as a parameter, store the result in a variable total. So we'll create a variable called total, and what we'll do is we'll call sum on numbers. What that means is if I had a list called numbers with numbers 1, 2, 3, 4, and 5, I can call the function sum on my numbers. I'm gonna have to do print so it can print it out. And once I run this piece of code, you can see that it sums it up. 1 plus 2, 1 plus 2 plus 3 plus 4 plus 5 is indeed 15. And therefore you get 15. So sum function just sums all of the numbers in a given list. Okay, store the result in a variable called total. Like the example of use float to convert total and store the result in total. So what I can do is I can call float right here, but that will probably confuse you guys a little bit. So I'm gonna make it simpler, and I'm gonna say new total is just equal to float of total. All that does is really like put a decimal place in front of total, so it says Python, make sure that this is saved as a float number, because I also want, when I do some division with it, I also want to keep the decimal values. It's important for me. And so we say that's okay. Divide the total by the length of the numbers list. Use the built-in length function. So how do I get an average of anything? Well, you just add those things up and you divide by how many there are. So to get an average of 1 plus 2 plus 3 plus 4 plus 5, I would say 1 plus 2 plus 3 plus 4 plus 5, 15, right? And then I'll divide it by how many things there are. So if I count, I have 1, 2, 3, 4, 5 elements in this list. So I'll say 5. So 15 divided by 5, that gives me back 3. So the average of numbers does effectively give me back 3. And you can also visually look at it. 3 lies right in the middle, so you can know that this has an average of 3. But if it was a little bit more complicated, or for some different number, now 3 would not be the average. But if you did the math how I told you to do it, it would work. So don't be lazy. If averages aren't so natural to you, go ahead and actually compute the average of this. Add all of the 5 numbers and then divide by 5. So that's what they want you to do. Okay? One quick way to do it is, well, how can you write a certain thing that always knows how many numbers to divide by, right? So if I want to do average of, let's say, numbers, how would I do that? Well, I will use one function to help me, which will sum up the numbers. So now I know already this is 15. But how do I get where it does 15 divided by 5? I know I can hard code it. Okay, but what if there was only one number in the list? Now you would have 1 divided by 5, which gives you a nonsensical answer, because that would not be the average of that. So how can we get the number of the items in the list and divide by that, even if the list is dynamic or it keeps changing? Well, that is why the len function was built. That tells you how many items there are. So we take the sum of all the numbers and we divide by the length of the items in the list, so how many items there are. In this case, this part turns out to be 15, this part turns out to be 5, nice and easy. We get the average of, let's call it, of numbers is 3. So let's see what they want us to do. Divide total by the length of the numbers list. Use the built-in len function to calculate that. So I'm going to say that I'm going to say return total by the length, divide total by the, so in this case they just want us to divide total by the length of the numbers list, because we've already summed it, right? So I'm going to say total divided by the length of that list that we passed this function. So again, this is a function that's taking in a parameter. Make sure you understand what that is. The parameter here is numbers. Okay? Now, that means that when we call this function, we have to give it one argument, one thing in the parentheses, and then it goes through and does something with it. A challenge I give you is write a function that takes in, that sums up 2 numbers. Okay, it takes in as input 2 numbers and it returns their sum. So I challenge you to write that, and I'm going to quickly show you the answer. So pause your videos if you want to try it, but here would be the answer to that. Define, I'll call that function sum a b, return a plus b. That's it. Okay, but this is my way of checking if you know what you're doing. This is a good way to check your knowledge about functions. Okay, so I think that should be good. Start next lesson. Just wait and see. So I assume this has to do something with weights. They're nice little lame jokes sneaking in. Now we need to compute a student's average using weighted averages. So students' weighted averages, right? What does a weighted average mean? Well, does 100 on your homework mean the same thing as 100 on your test? Absolutely not. Maybe 20 of your homework assignments or more might mean that, right? Maybe if you do 20 homework assignments or you get 100, that might mean one test score of 100. So tests are a big deal, so they need to be weighted differently when we're calculating the actual grade. So that's what they're doing here, right? They're using 0.9 times average of cost of apples. So here they're taking the average cost of the apple. So they just create a function called average to make their life easier. And so did we. And now once you make something a function, you can just use that function. So they're using the average function to compute the cost of the apple, and then they're multiplying that by 0.9. And then they're doing the same thing for bananas down here, right? You see the division sign? So they're doing the same thing for bananas right here, except they're multiplying it by what? 0.1. This probably means that they hate bananas, or for some reason they value apples more. So they're multiplying it by a higher number. And for bananas, it's, the inverse of what I just said. Okay, in the above example, we we weigh the average cost of bananas by 90%, right? 0.9 is 90%. And the average cost of bananas by 10%. So, I'm sorry, this is not division, this is continuation, okay? I'm throwing you guys off. This just means line continuation. This is a really ugly thing to do, and you should try to avoid doing this at all costs if you must. That it makes the code harder to read, and as you can see, I made a mistake when I was reading it. This is pretty much, you could just ignore it. Okay, this takes no effect. So it's basically 0.9 times average cost of apple plus 0.1 times average cost of bananas. Write a function called getAverage that takes a student dictionary like Lloyd, Alice, Tyler as input and returns her weighted average. Okay, so step 1, we define a function called getAverage. Okay, define getAverage right here. Takes in one argument called student, make a variable homework that stores the average of student homework. So effectively what this is doing, this function getAverage here, is that we give it a student name. Let's say we give it a Lloyd, right? And then what it would do is it'll store in homework the average of that student's homework score. So it'll do that homework, right? We'll go to the value that we get. If we use the dictionary Lloyd with the key homework, we get back this, calling the average function on that list right there, right? Calling this average function. So what it does is it takes this, gives that to the average definition of the function, gives that right there to average. And then on line 22, it replaces this with that. The sum of all of this would be what? 90 plus 97 plus 75 plus 92. That gives you 354. This float total turns that into 354.0 because of float. And then you get 354.0 divided by length of numbers. In this case, the length of numbers is 4. And you get back 354 divided by 4, 88.5. And once that is returned, this part here gets turned into 88.5, and so then homework gets stored as 88.5. How cool is that? Right? Programming is so cool. We define these algorithms once and then do monstrous amounts of work in less than milliseconds. right? I find that really cool. And what we're doing is we're creating our own functions, and then we are already ready to leverage it, right? We're already leveraging that in our continuous functions that we're writing. So that is the definition of good code, how reusable it can be. All right, so repeat step 2 for quizzes and tests. Okay, so now we do the same thing for define, get. Oh, step 2 for quizzes and tests. Okay, so step 2 is just this. And here I will change this with quizzes, and the variable I'll change it with, with quizzes, and then I'll do the same thing right here, tests. Okay, that's some keyboard ninjaing skills that I've developed over the years. Multiply the 3 averages by their weights and return the sum of those 3. So multiply the averages by their weights and return the sum of those 3. So now I will say weighted. I'm gonna write this code in a cleaner way because they want us to write everything on one line. Weighted homework is equal to homework times, well, it's at 10%. Homework is 10%, which means, this means 10%. Okay, I'm not gonna write the 0, but you can if you want. 0.1 is just 10%, but okay, I'll write the 0 there to just make it very clear what it is. Okay, and then I will do weighted quizzes is equal to quizzes multiplied by 30%, weighted tests equal to tests multiplied by 60%. You get the idea. And now we'll just return weighted homework plus weighted quizzes plus weighted tests. Right? Is that what they want us to do? They didn't say return, but I returned it anyways. Sending a letter. Great work. Now let's write get letter grade function that takes a number score as input and returns a string with the letter grade that the student should receive. Okay, so now what they want us to do is create a function that will take in whatever this average grade is that the student got and convert it to a letter. Okay, so that's pretty cool, right? We get back, let's say 70. We turn that into a C, slap that onto the report card. Our loop continues running, goes to the next student, sees he got 85. In our case, might be Lloyd or whoever, Alice. Sees that, she got a 75, slaps a C, sends it. Next gets Tyler, sees a 95, slaps on an A, and sends that card, a report card, to his father, and father is happy and up in arms. Okay, define a function called getLetterGrade. Okay, I have to do def, right? It's a function that has one argument called score. Expect score to be a number, so score is going to be a number. If this was professional code, I would write some documentation, as in something like, I would say parameter score is an int, something like that. But I'm not going to do that right now. Score to be a number. Inside your function, test score using a chain of if, else statements like so. If score is greater than or equal to 0, right? We have to translate English to code. That's what you'll have to do if you have a job or you're just trying to create a fun game. First, you'll have to think of it in English, then translate it into code. Then it's easier. So if score is 90 or above, right? I'm just writing that in Python, nothing special. I'm saying if score is greater than or equal to 90, I will say return A. Else, if score is greater than or equal to 80, return B. Else, if score is greater than or equal to 70, return C. Else, if score is greater than or equal to 60, return D. And now for the last one, okay, how I think of it is this is an if statement, this is a condition, and then this is what happens when that condition is true. For your else statements, you don't need a condition, so you can just write else like this. So now think about it. Should we write another else if statement, which is elif, E-L-I-F, or should we write an else statement? What do you think? We should write an else statement. We could write an elif statement saying if score is less than 60, right? Anything less than 60, give them an F. But why write more code when we can keep it more elegant and just say else and say return F, right? That makes it real elegant. And that's all that getLetter should do. Finally, test your function called getLetterGrade function with the result of print the resulting grade. So print, and I'm gonna call the getLetterGrade function, and it takes in a score, so it's dependent on a score. So I'll do get average. I'll pass Lloyd to get average, and my parentheses should be correct. So this part will get the average and it'll get evaluated to some number, let's say 85. I don't know what it is. And then the getLetterGrade function gets called on 85. That goes through that loop. It converts that to B. That's what should actually theoretically happen, and print out B, let's say. So let's give this bad boy a try, and actually we did get a B. I didn't know what Lloyd's average was gonna be, but that's what we ended up getting. Okay, now just to blow your minds, I'm gonna take you through actually what the algorithm is doing, the whole 9 yards. If you don't want to do it, you want to watch this part because you're like, I'm sure I got it down, skip it. But I will walk through it really quickly so you can know what's going on. Okay, this will give you a very good idea of everything that's happening under the hood. Okay, so let's say we call these functions in this order. Okay, now getAverage function gets called. Okay, the getAverage function gets called. So we go to getAverage. It goes here, it passes in Lloyd, because to get average we gave the argument Lloyd. So everywhere it sees get average, it passes in everywhere it sees student, it passes in Lloyd. So this turns into Lloyd, this turns into Lloyd, this turns into Lloyd, and then it starts getting evaluated, right? So this part gets evaluated to Lloyd's homework, which is this. This part gets evaluated, the next part gets evaluated to Lloyd's quizzes, which is right here, and the third part gets evaluated to Lloyd's tests, and we get back a 75, 90 here. Now, actually, it happens in a different order, right? This whole part gets evaluated first, but just to make things simple, I'm keeping it like this. Now we have the average function being called on this list right here. So what happens here is we pass this list to the average function. So everywhere you see numbers, that list gets passed. So we pass that list. This sum right here calculates this to 90 plus 97 plus 75. I think that's 354, right? Yep, we've done this before. 354. This part makes it 354.0. This part makes it 354.0 divided by 4. 354 divided by 0.0 divided by 4 makes it 88.5. That returns 88.5. So for Lloyd's homework, we get 88.5. Now, for Lloyd's average, the same thing happens. We pass in this argument to the function average. So it passes this guy. Wait, what was it before? I feel like I deleted something. Okay, so let's just keep it. Now, in total, this number changes to that. So the sum function gets called. It sums up all those numbers. That gives you a 222 right here. We put in 222 in here. This turns it into a 222.0. We get 222.0 divided by the length of this list right here. The length, numbers, the length of that list is actually 3. So 222 divided by 3 gives you 74, right? So effectively we have 74. I forgot what the other score was. It was 354 divided by, how many homeworks did he have? 4, right? It was 88.5. So 88.5. I'm just going to keep that up there to keep track of it a little bit. Now for tests, the same thing happens for Lloyd, right? We pass in this test right here. This test gets put right there. Now it goes to average. It passes in that list to the argument average. Everywhere you see numbers, you get that. Sum of 75 plus 90 gives you back 165, right? 165, it gets called on this float of 165. That gives you 165.0. 165.0 divided by the length of the numbers, which is 2. 165 divided by 2 gives you 82.5. So we get back an 82.5, and ultimately we end up, so test is 82.5. When we computed quizzes, it was 74. When we computed homework, it was 88.5. Right? These were the values. Then effectively what happened right around these lines of code, now these lines of code run. So we take 10% of 88.5, 88.5 times 0.1, you get 8.85. So this whole part turns into 8.85. For quizzes, what's 74? 30% of 74. That part turns into, what was it? Just to double check, it turns into 22.2. This part right here turns into 82.5 times 0.6, 49.5. So what do we have here? 8.5 plus 22.2 plus 49.5, 8.85 plus 22.2 plus 49.5, 80.55, right? So it returns 80.55. So this whole part gets evaluated to 80.55, and then this function gets called now, get letter grade function. So this 80.55 gets called, gets passed to the function get letter grade. So now score is 80.55. And it goes, if score is greater than or equal to 90, score is actually 80.55. So this part evaluates to false. These lines of code don't run. Then it goes to line 42. Else if score is greater than or equal to 80, score is 80.55. is 80.55 greater than or equal to 80? True. This part of value is so true. And so it returns B. This whole part gets evaluated to B, and it ultimately prints out B to the screen, which is what you guys got right there. So this video, whew, oh boy, hopefully that just blew your mind, right? That was really powerful. There's a lot of brain work involved that's going on there. But when you're writing all this step by step and you're writing it methodically, you're not doing all that in your head all the time, right? Once you're done writing it, computer takes care of all the logic and all the hard work. I mean, computer takes care of all the hard work. You just write the logic part. And when you do it step by step, it's simple. First step, write a thing that does average. Second step, write a thing that gets average and weights the homeworks based on the average function we previously created. Third step, write a get letter grade function, which uses our previous two functions. And get letter grade, all its job is to return, to take a score, a number, and convert it basically to a letter, right? You guys, that was a very exhaustive video, but if you've stuck through it and saw the explanation step by step, I guarantee you now have a better understanding than 99.999999% of the people who have made it this far in the Codecademy course, because they don't take the time to go through the fundamentals. You have taken that time and put in that effort to get past those types of fundamentals and sit through and watch it. Your neural pathways in your brain are getting stronger because of that, right? So what that means is all of this stuff is going to be more normal to you now. It's going to be more natural to you. You're not going to have to squeeze your brain all the time to think about it. That's why I'm trying to create a pattern recognition here. Constantly going through if statements, constantly going through loops and functions, arguments, all of that. All right, that's it for Codecademy Part 12. I will see you in the next video. Codecademy Part 13. This is Kazi from cleverprogrammer.com. See you in the next video.